In this video, we are going to talk about APIs and specifically REST APIs. Here is what we're gonna cover. What APIs are, what REST APIs are, and how they work. We're gonna discuss basics of REST, including request response cycle, and some important things that you should be aware of when working with REST APIs in real life. Let me show you an API you've probably used today without realizing it. When you check your weather app, you see the weather immediately. But here's what you don't see. This app just grabbed real-time data and delivered it to your phone in milliseconds. That's APIs working behind the scenes. So what exactly is an API? API stands for Application Programming Interface. Now, the keyword here is interface. An interface is a set of controls and methods you use to interact with something complex underneath, without needing to understand how that complex thing actually works. A great analogy for an API would be an electrical outlet. You plug in your phone charger and get electricity. You don't need to know where the power comes from, how the grid works. You just know, plug in here and get power. The outlet is a standardized interface. There's different types of outlets, but they all deliver electricity the same way. APIs work exactly like this. There's REST, there's GraphQL, there's gRPC. REST, GraphQL, and gRPC aren't APIs themselves. They're different standards or approaches that define how APIs communicate, just like different outlet types define how devices connect to electricity. An API is an abstraction layer. Abstraction means hiding complexity behind a simple interface. For example, a steering wheel and pedals hide thousands of mechanical systems, but you don't need to know how those systems work. All you need to know is how to use the steering wheel and the pedals. APIs are the same way. They hide implementation details and expose only what other programs need to know. APIs aren't just for the web. Operating systems expose APIs, programming languages expose APIs, hardware devices expose APIs. You interact with APIs all the time. You just never see them. Today, we're gonna focus on REST because REST is what powers most of the web applications you use daily. A typical web application has two parts. The front end, which is everything you see and interact with. Buttons, text, images, forms. It runs in your browser or on your phone. That's the client. Then there's also the backend. Backend is where most of the work happens. Business logic, data processing, databases, all of these run on remote servers you never see. So here's the question: how does the front end talk to the backend? This is where REST APIs come in. REST stands for Representational State Transfer. REST is an architectural style. It's a set of guidelines for building APIs on top of HTTP. Here's the important part. They're just conventions, but here's why you should follow them. When you follow REST conventions, your APIs become predictable. Other developers immediately understand how to use it. So while REST is guidelines, not law, treating it seriously will make your life easier and your APIs better. Let's take a look at key principles of REST. Client-server separation. This simply means that front end is completely separate from the back end. They are independent pieces. Stateless. This means each request you send to the server has to include everything the server needs to understand and fulfill that request. The server doesn't need to remember anything about your previous requests. Why does it matter? Because it makes scaling really easy. If the server does not need to remember anything, any server in a cluster can handle any request. Cacheable. This means the server tells the client whether a response can be reused or not. If something is cacheable, the client can save the response and reuse it instead of asking the server again. The server might say, hey, this weather data is good for the next hour. Don't bother asking me again during this time. That's caching. Why does it matter? It makes your application faster, reduces the load on the server, and saves bandwidth. Uniform interface. This is a fancy way of saying everything works in a predictable, consistent way. Resources are identified by URLs. Actions are defined by HTTP methods. Responses come back in standard formats. Once you learn how one REST API works, you can figure out other REST APIs pretty quickly because they follow the same patterns. Layered system. This means the client doesn't know, it doesn't need to know whether it's talking directly to the final server or going through intermediaries. Your request might pass through a content delivery network, then load balancer, then a security gateway, and finally reach the actual server. But from client's perspective, it just looks like one API. So how do these REST principles actually work in practice? It all comes down to a request-response pattern. Your app, the client, sends a request to a server. The server processes that request and sends back a response. That's it. Every API interaction follows this same basic pattern. Let's make this concrete with an example. A user wants to find information about their favorite movie, Inception. They open a movie database app, type Inception, and hit search. Instantly, they see results: title, director, year, rating. Here's what happens behind the scenes to make that work. The front end, your movie app, sends a request to the server. The request includes everything the server needs: search query Inception, authentication credentials. The server receives the request, it validates the request, then it queries the database for movies matching Inception. Finally, it formats the results into a structured response. Then it sends back the response containing the data as well as the status code. In this case, 200 OK means success. When the front end receives the response, parses the JSON, and shows the data to the user. Now let's break down exactly what's in the URL, because each part has a specific purpose. First, there is a scheme followed by a protocol separator. Then there is a base URL followed by path and hierarchy separator, a path followed by query parameter introduction, and finally there is query parameter. Let's examine each one. First, the scheme, HTTPS. This tells us the protocol, how data gets transferred. HTTPS is HTTP with encryption, which secures the connection between your app and the server. Next, the base URL. This is the host, the domain name that resolves to the server's IP address. It tells your app which server to contact. Then there is the path. This specifies the resource or endpoint on that server. It's telling the API, I want to use your search function. And finally, the query parameter. This is how we pass specific data to the endpoint. The question mark starts the query string, and we're saying we are looking for a movie with the title Inception. Here's the key. You can't just make these up. Every API documents exactly what paths and parameters it accepts. The documentation is your contract. You follow what the API specifies, not what you think might work. Now let's talk about HTTP methods. You've probably heard the term CRUD. CRUD stands for create, read, update, delete. The 4 basic operations you can perform on data. These 4 operations cover majority of what you do with a database or API. Now let's see how REST maps these operations directly to HTTP methods. So GET is for reading data. You're asking the server, show me this resource. GET requests never modify data. They only retrieve it. POST is for creating new data. You're sending information to the server and saying, add this as a new resource. PUT and patch are for updating existing data. PUT typically replaces the entire resource, while patch modifies just specific fields. You'll see both in practice. And delete is for removing data. Straightforward. You're telling the server to delete a specific resource. The methods tell you the action. The URL tells you the resource. Together, they describe exactly what you want to do. When the server responds, it includes a status code, a 3-digit number that tells you exactly what happened. There are dozens of status codes, but here are the most common ones you'll encounter. 200 OK means success, your request worked, and here's the data you asked for. 401 means unauthorized. It means authentication failed. Either you didn't send credentials or they are invalid. 404 means not found. The resource doesn't exist. The URL you requested isn't there. 429 means you've hit the rate limit. You've made too many requests in a short time and the server is telling you to slow down. 500 means internal server error. It means something broke on the server side and it is not your fault. The server encountered an error it couldn't handle. Did you notice the pattern? Status codes into hundreds mean success. 400s mean there is an issue with your request, something you need to fix. 500s mean the server has a problem, something on their end is broken. There are several authentication methods you'll see in web applications. Things like OAuth, Basic Auth, and JOT. But for most public REST APIs you'll use, as a beginner, authentication is done with a simple API key. So that's where we'll focus on. API keys are simple. Here's how they work. You sign up with the API provider and get a unique key. You include that key in your request. Where exactly? Check the documentation. Some APIs want it in the header, some in the query parameter. The header name varies too. Then the server validates the key and responds. If the key is valid, you get your data. If it is invalid or missing, you get a 401 unauthorized error. Always check the docs for information on how to authenticate. Now you understand the basics of how REST APIs work, but there are some practical issues that you should be aware of. The first thing is rate limits. Most APIs limit how many requests you can make in a given time period. If you make too many requests too fast, you'll run out of quota. Some APIs send headers that tell you exactly where you stand, how many requests you have left, when your limit resets. These are incredibly useful if they're available, but not all APIs send these headers. Always check the the documentation to see how rate limiting works for that specific API. Next, API keys are passwords. Never store your keys in front-end or client-side code because anybody can see them there. Never commit them to Git, whether it is a public or private repository. Always use environment variables. Keep your keys out of your codebase entirely. If a key gets compromised, rotate it immediately. Always read the official documentation. The official documentation is your source of truth. It's your contract with the API provider. When something doesn't work, this is where you go first. Treat documentation as essential, not optional. Here are a few more things you'll run into in practice. APIs will fail. Don't assume every request will succeed. Build your applications to handle failures. Add retries, timeouts, fallbacks. Expect things to break. Always check the terms of service. Some APIs prohibit storing data. Some require attribution. Some have restrictions on commercial use. Read the terms before you build your entire app around an API. Free tiers run out fast. That generous-looking free quota can disappear quickly in production. Be mindful of your usage and have a plan for when you hit limits. And remember, trust official documentation only. Everything else might be outdated or incomplete. Let me show you a real API request in action. I'm going to call a simple cat facts API. This is a public API that does not require authentication, which is perfect for this demonstration. We are sending a GET request to facts endpoint. No authentication needed. So here's the response. Status code is 200. Okay, that means success. The server received our request and processed it successfully. Content type tells us that the response is JSON data. And here's the actual data, a JSON object with a random cat fact and its character length. Now let me show you what happens when you provide incorrect endpoint. I'm going to send a request to an endpoint that does not exist. Status code 404 not found. The server responded. Notice that it didn't just ignore our request, but it told us what went wrong. 404 is in the 400 range, which means that it is a client error. We asked for something that does not exist. It is our mistake, not the server's. In the next video, we'll build a full app that talks to 3 different APIs. You'll see all of this in action, including how to handle errors, manage rate limits, and keep your API keys secure. If you made it this far, subscribe to see more videos like this. And if you found this helpful, like the video. It genuinely helps more people discover it. Thank you for watching, and see you next time.